All right, so we just finished classifying. So now we're going to go to separating the mixtures. Because remember, the mixtures are the ones that you can see. So first thing is you got physical separation. These are of mixtures, right? So you can physically separate them by moving the parts in order. Physical is moving parts in order to separate them. Here's a couple examples of physical separation. Filtration. This is like if you have sand and water and you want to separate them, you put it through a filter paper. Think of like coffee too, right? So you put the coffee beans in there and you filter out the liquid which you want to drink. And then you have chromatography, where you want to separate the colors that make up a specific ink type. And then you've got distillation right here, and this is separating based off a boiling point. Magnetism, anything that's magnetic, say you've got sand and iron filings all mixed up together, you could use a magnet to separate those. And then last but not least, evaporation, because we have different boiling points, you have different evaporation points. So filtration, this separates solubles from insolubles, like hard stuff from liquid. Then we've got, what would you use to separate water from salt water? Like how would you get it fresh water? This is where you'd want distillation. So what you would do is you would separate based off of boiling points, right? So if I was to boil salt water, the water would boil off, right? Like it would boil off and evaporate because the salt would come out. Like salt has a higher boiling point than water. So water would boil off first, come up through this little system, cool off, condense, and then drip back down here. I will be showing you guys one of these soon. And then the salt would remain in the container until it hit its boiling point, which it probably wouldn't because it probably burned. All right. Okay. So how could you separate dyes, even ink? This is where you get chromatography. So you would set up a mobile phase, which in certain cases could be like alcohol, could even be water, if you have a water soluble. And you would put in like a filter type paper, and you would put a dot of whatever you're trying to separate above where the water level would touch. And then you would let the water rise out, and as the water rises or the alcohol, it will pull the ink or the dyes out and separate them based on their different colors. Separate iron and gold. You'd want to separate using magnets. You could put a magnet near it and it would pull stuff down. So magnetic properties, anything magnetic, you want to separate using a magnet. If it's reactive, you want to add acid, which we're not going to be doing right now. Okay, so properties of matter. We've got physical properties and chemical properties. Physical, this is observed with the senses. Anything physical, you're observing it, you're looking at it, you're hearing it, you're tasting it, not really tasting, touching it, maybe not touching, hearing it. Measured without destroying that object. You can observe color, shape, mass, length, boiling point, melting point, solubility, density. Yes, boiling point. All you're doing is changing it from one state to another. So it's not really destroying what was there. Chemical, however, how it reacts or fails to react with another. That's that reactivity we were talking about. That's a chemical reaction or a chemical property. So a physical change. They do not change the identity of the substance. This is cutting, tearing, kind of like what I did in class where I ripped the paper in half. It's keeping the same, it's the same thing, only it's split in half, right? Tearing, shredding, phase changes, like I said with that. Going from a solid to a liquid to a gas. They're all the same thing. They're just changing phase. Dissolving, that is also a physical change. That's taking salt. I dissolve it into water to make salt water. I take sugar and dissolve it into my tea to make a sugary tea. Chemical change. Now here's the big thing. Chemical change comes from chemical reactions. It is changing the identity of that substance and something new is made. This is like cooking. You can crack open an egg, splat it down onto the frying pan, and it will turn into a fried egg. But you're like, hey, miss, it's still an egg. But can you make it back into the original thing? So physical, you can always bring it back to the original state, the original thing that you started with. Chemical, you can't. So like you have a mixture. I made pancakes the other day. I mixed up the pancakes with the water. I mixed it up. I cannot go back and make that separate it to a water to the powdery form. I can't. Once it's done, it's done. And once I cook it, I can't bring it back to those. So burning also, if I burn paper, I can't bring it back to the original paper. Exploding, yeah, no, we're not going to do exploding. Reacting, interreacting, not reacting, not interreacting, spoiling, rusting, oxidizing, all that stuff is chemical change. It is typically, you can see this by being accompanied by a release of light or heat. You see that with cooking. There's a release of heat. Formation of a precipitate. If something forms out of water, which we'll see in a while, a precipitate, if something forms out of it, there's a chemical change. Something new was made. A production of a gas. If I make oxygen with it, if I make carbon dioxide with it, that produces a gas. So what I'd like you to do now, you're going to go to the travelogue, you're going to finish up in class, you're going to finish up the side. Let me explain that a little bit further. And there's a worksheet, green worksheet in the back, says matter classification. Next thing up, we are going to do a classification lab. All right, that is it for today. If you have any questions, let me know.